everyone. Today we are starting with chapter 1 and you are in the chemistry class. So in this chapter you're going to learn about chemistry. Also in this chapter we are going to define a few foundations like what is science, what is chemistry, what is technology. We will also learn the principles of green chemistry, what is sustainable chemistry, how does the scientific process work? For example, what is a law? What is a hypothesis? What is a scientific theory? And things like that. And in later part of the chapter, we are going to learn about the matter and different terms and terminologies in chemistry. So let's begin. Chemistry is called the science of all seasons, and the reason for that is if you look around in our daily life, everything we do involves chemistry. So chemistry is a study of matter and its changes. So here you see cooking involves chemistry, or when you go to buy vegetables, they involve certain chemistry. Our hair, soaps, detergents, in agriculture, in medicine, you have numerous applications of chemistry, and we'll see that in later in the chapter. So let's come to so you know you are taking a chemistry class, and you know chemistry is a science, but what is science? So science is the process of seeking an understanding of the underlying principles of the nature. So when I talk about science and technology, the second term is technology. And science usually involves two interrelated facets. One is technological, which is factual, and other part of science is philosophical, which is theoretical aspect. So technology is something where you see a direct application of the knowledge, and that leads you to solving the problems. You get a solution out of it. And science grew out of this natural philosophy or the philosophical speculations about the nature. So in centuries ago, it begins with the Greek philosophers observing nature and starting to think about it, and then form the natural philosophy, and that led to observations, experiments, and then laid the foundation of science. So if I have to define again, science is a process of seeking an understanding of the principles, underlying principles of nature. And we learned the technological and the philosophical aspect of science. So chemistry, if I have to define it, is a discipline of science that deals with the behavior of matter. And here I'm going to introduce a little bit about Baconian dream and Carsonian nightmare. So these are the two different principles, and what it says is Francis Bacon, who was an English philosopher, he had a dream that science would lead to solving world's problems, and science will help human life, will enrich the human life with new inventions, and that will lead to more happiness and prosperity for the human society. That's a dream by Francis Bacon. And then here we have Rachel Carson, who is a biologist and who published a very famous book called Silent Spring in 1962. And this was the first ever publication to point out several serious environmental issues, such as disappearance of fish and birds because of the pollutants. And so she proposed that using chemicals was basically threatening or leading to destruction of life. So that's her nightmare, Carsonian nightmare. And in response to the growing public concern after reading the books and the protests, people developed the concept of green chemistry. So that led to something positive. And green chemistry, as you all might have heard in your day-to-day life, it uses materials and processes which will prevent or reduce pollution at its source. So before the pollution is even generated, you try to prevent it or you try to reduce it from its source. And sustainable chemistry, the concept of sustainable chemistry comes from the design to meet the needs of the future generations. So whatever we have, do not, like, without compromising the need, whatever we have, sustain it so that the next future generations can enjoy that, enjoy the environment, or things related to that. So sustainable world or sustainable chemistry. So now we're going to focus on 5 characteristics of the science. And as we know, science is the primary means to obtain new knowledge. Okay, so science is testable, science is reproducible, it is explanatory, it is predictive, and it's tentative. So what that means is, so these are the 5 characteristics of science that we saw. And a process of science is made up of several components, or it undergoes several steps. So first is scientific hypothesis. So scientific hypotheses are testable explanations of observed data. So a scientist makes an observation and then hypothesize what could be the explanation for that, and then those hypotheses are tested by designing suitable experiments and then performing those experiments and then observe the results for that hypothesis. So it is testable. Scientific laws is another term that we often hear about, and these laws, what they do is they summarize large amounts of scientific data, and from that data provide description of the natural phenomenon. So scientific laws are universal. That means whatever you are observing here will be applicable in any other part of the universe as well. Mostly we are talking about our universe. So example, law of gravity, that's applicable in the US. It's also applicable in any other part of the world or in the universe. And many scientific laws, they can be stated mathematically. So you can actually solve for those laws. For example, later in the class, you're going to learn about the gas laws, and one of them is Boyle's law, and it's telling you that pressure and volume is equal to a constant, or pressure and volume are directly proportional to each other. So many scientific laws can be stated mathematically. Moving on, scientific theory. So scientific theory is another term. So basically it's a set of tested hypotheses which explain a natural phenomenon. So they are the best current applications for the natural phenomenon. Now keep in mind that these theories are also useful for their predictive value. So depending on the current data, you could propose what could happen. So you can predict the value, and if the set of conditions differ, then those theories can change. So the theories are always tentative and they can change as observation of nature changes. And then is the scientific models. So you should be able to explain science by using these models. So here is one such scientific model explained. So basically the models use either tangible pictures or items to represent something that is not visible with our eyes to explain. So for example, here you have beaker A and beaker B, and in this beaker you have water. So water is in the beaker, and then when you're going from condition A to B, you see the amount of water is reduced in beaker B. So if I have to explain this through a model, we know that evaporation is happening, right? Over the time, the water is evaporated. But how do we explain it? By using some models. So here in the circle, you can see different models. So I have, or in this model, water is represented by this blue balls, and then air is represented by this gray ball. So over a period of time, the water in container A is left open in the air. So what happens? The water evaporates slowly. So this is what is being shown in the arrows here. So the water molecule is going up in the air and then evaporating. And in part 2, you see now the amount of water molecules are less and more water is in the air, and that's explained by these arrows showing you the motion of molecules. So basically evaporation is explained in the scientific model with the help of scientific model. Scientists or chemists also use this molecular modeling where before I go for molecular modeling, let me explain what is molecules. So molecules are groups of 2 or more atoms which are held together by chemical bonds, and we'll learn about chemical bonds later. But for now, they are groups of atoms, a group of 2 or more atoms held together. So the example would be an oxygen molecule. So oxygen 1 atom, oxygen 2 atom, they will bond together to form oxygen molecule, which is O2. Or another example is water molecule, where you have 2 hydrogen atoms and 1 oxygen atom forming H2O, which is the molecule of water. So next then we have molecular models. So molecular models are 3-dimensional representations of the molecules. So here is an example of a diamond. A diamond is shown here, a picture of diamond, and then over here a molecular model is shown for the diamond. So basically it's telling you how all these atoms in the diamond, which is the carbon atoms, are held together by tightly linking each atom to the other, and this tight linking leads to a rigid structure of diamond, and that's one of the reasons why diamond is so hard. So we learned about science. Now what are the limitations of science? So science is limited to studying what is observable, as well as the processes in which the variables can be controlled. So you observe it, hypothesize it, do experiments, check the results, form theories. Theories are again checked, and if the results are favorable, then they form laws, and then the laws become universal, right? But um, if the variables are changed, then you know the theories are tentative and that they can change with the changing variables. So that's the limitation of the science. Another term that I'm going to introduce now is risk and benefits. So with science and technology, these things come. So as I told you before, science and technology are both interrelated, and they both involve risk and benefits. So, and usually this risk benefit analysis is done by something called as desirability quotient, DQ, and DQ is defined as or is equal to benefits divided by the risk. So think of milk, for example. So many people, for them, milk is a wholesome food. And for some people who are lactose intolerant, that's not the case, right? That's milk. It is difficult to digest milk. However, for when these desirability quotient is calculated, you always see what are the benefits of milk and what are the risks of milk, and the milk's benefits usually outweigh its risk for large population. So that's one example. And here is a table where you see different causes of deaths in United States. So you have things like all the causes together, how many deaths are caused by cigarette or cancer or accidents or airplane accidents or peanut butter, and here is the lifetime risk set. So the odd of dying of a particular cause in a given year is calculated by dividing the population by the number of deaths, okay, within that year. And then you have approximate lifetime odds, and later on the last column you have details over assumptions. So this is how you weigh the desirability quotient of that thing, of that scenario. So for example, lifetime risk is 1 in 1 chances, and the details or assumptions are everyone dies of something. Then you have something like heart disease, which is a medical condition, and the lifetime risk is 0.20, and then the approximate lifetime odd is 1 in 5, and then the assumption or the details is heart attacks or the congestive heart failure. So this is how people can approximate the lifetime risks. The milk example better to explain it. Okay, so here is a diagram which explains you why chemistry is a central science and how chemistry is involved in all the areas of our daily lives, as I suggested as I started the chapter with. So there are various examples of use of chemistry. So here chemistry is a central role. You find its applications in medicine, in studying brain, neurology, paleontology, geology, physics, electronics, climate change or the weather studies or meteorology, metallurgy, studying of metals, engineering, archaeology, agriculture, biology, biochemistry, toxicology. So here are some of the examples to explain the role of chemistry.